Okay, all right. Greetings and welcome, friends. Today we're going to learn a couple more identities. Isn't it great? These things are just still coming at us. I love it. We're talking today specifically about double angle and half angle identities. So yesterday we talked about sum and difference, right? So if I knew some angles, right, I was able to use those. But what if I want to specifically be able to double something? So let's start with deriving one of these identities. We're going to prove this to you. If I want to calculate what sine of 2 theta is, all right, and also note this is not sine squared theta, all right? Notice the subtle difference. This is like a big 2. This is like a little 2, and that theta just lost its horizontal line part there. So big difference. Try to be particular in how you write so that you don't end up accidentally switching that for that later on. I almost did that earlier today. So sine of 2 theta. Turns out I could derive the identity for sine of 2 theta using one of yesterday's identities. It's Friday. So sine of 2 theta is the same as what plus what, do you think? Well,
Sine of theta plus theta.
Theta plus theta is 2 theta. Sounds right to me. Okay, and according to the trig identity for that, I can replace that whole thing with the following. That's going to be sine theta cos theta. Let's see, is it plus or minus, friends? Plus, it matches for the sine one. And then cos theta sine theta, which you might realize those are like terms. How many of them do I have? 2 of them. So, all right, and that's multiply. So we've just derived one of the double angle identities, specifically the one for sine. What do you know? Sine of 2 theta happens to be 2 sine theta cos theta. Oddly enough. While we're at it, let's derive another one, just because we're on a roll here. I'm not going to derive all of them today, but it's worth seeing some of these. Cos 2 theta. How do you think we could do this one? It's the same as cosine of theta plus theta. What do we know? Good news, everyone. So I can now just interchange this with one of the identities from yesterday. And this is, by the way, often this is how math is discovered, right? You discover something is true, and then we can use that to prove other things are true. It's like math just keeps expanding, some sort of cool building block, Lego, Minecraft thing. So cosine theta plus theta, right, is equal to cos theta minus, because it's the opposite for the cosine different or sum identity, right? Sine theta. Okay. And how could I simplify this? What's this multiply to be? Cos squared theta. Notice the big 2, little 2. Big 2, little 2. So, big difference there. Minus sine squared theta. This happens to be one of the cosine identities. And notice I just said the word one of. Uh-oh. So let me give you the list of all the double angle identities. And I guess you guys technically have them on your sheet that I've already equipped you with, so you don't have to write them down again. But for the sake of our online viewers, enjoy right there. Now, so we've just proven this first one, that sine 2 theta is equal to that. We've proven this one. How do you think I could go from this one to this? Yeah. All right. If sine squared theta plus cos squared theta is equal to 1, then sine squared theta is equal to 1 minus cos squared theta, right? So you could actually replace this with a 1 minus cos squared theta, and this minus sign would distribute to it, right? And it'd be a minus 1 and a plus cos squared theta, which is where the 2 cos squared theta came from, and the minus 1. So these other two are just variations, Pythag variations of it. This one's a result of replacing the cos squared theta with 1 minus sine squared theta. So both of those are just variations of that. You do have to know all three, and actually your calculus instructor would require that you have these memorized. I don't think he's too picky about the tangent. No, I think he might be. I don't recall. But anyways, so these are just variations. And what's nice, it's actually a good thing that we have these options. Depending on what information I know, if I'm doing a double angle for cosine, I'll pick a different formula to work with to save myself some time. How would you have derived the tangent one? Ignoring even what it says, how do you think you could derive the tangent one? If I already know this and this, what could I do? What's tangent equal to? Sine over cosine. So tan of 2 theta must equal sine of 2 theta over cos 2 theta. So the tangent formula just comes as a result of doing this divided by this and doing some manipulation to it. And it's simplified there. So those are some of our double angle identities. So let's put these to use. I think someone's screaming over there in the next room. It's okay, I assume. Ba, 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 ba. So here we are. Take a gander at this, shall we? It says if sine of theta equals 2/3, and theta has its terminal side in the first quadrant. Ooh, my goodness, sneezes, friends. Find the exact value of sine of 2 theta. Interessante. So I'm looking for sine 2 theta. Remember, sine of 2 theta is equal to 2 times sine theta cos theta, right? According to our little formula. What fact was given to me?
Sine theta.
I already know sine theta. I'm looking for cos theta,
No. Oh.
right? Well, I need cos theta in order to find what I'm looking for. It's like a part of the quest. It's a multi-part quest we're on right here, basically. So I could find cos theta using the Pythag identity, which you guys have done lots and lots of times. Actually, tell you what, let me show you another way to find cos theta. You might like this way better. So if sine theta is 2/3, let's draw a triangle. How do I know that's true?
Because it's adjacent over opposite.
Right? Sine, from angle theta's perspective, is opposite over hypotenuse. So the ratio of the opposite to hypotenuse is 2/3. I technically can't guarantee that it's 2 to 3, or 2 and 3 are the dimensions, but I know the ratio holds for that, and that's really all I need anyway. So if I want to find cosine from this angle's perspective, I just need to know what the adjacent is and relate that to the hypotenuse, right? So how could I quickly find that? Well, it's still going to be kind of the same work. It would just be, if I call this a for adjacent, I would just do a squared plus 2 squared equals 3 squared, right? So a squared plus 4 equals 9, a squared equals 5, a is equal to the square root of 5. And how does that help me? What's cosine theta equal to? No? From theta's perspective, what's cosine? Adjacent to the hypotenuse. So it's going to be the square root of 5 divided by 3. Okay, so this is a slightly different route to find cosine. if you were interested, if you're getting sick of using the Pythag identity. But also notice we're still using the Pythagorean theorem in there, but you're not using fractions in the process. I don't know if it's necessarily any easier, but I just want to show you that there's an alternative approach. So that means sine of 2 theta is equal to 2 times sine of theta was 2/3 times cos theta was root 5/3. So let's simplify this. This is going to be 4 roots of 5 all over 9. All right. So that's a way that I can go from the sine of one angle with its ratio and then find the ratio of sine of double its angle. Okay? So interesting stuff here. Interesting stuff. Now, let's do the same sort of thing except with cosine now on another problem. I mean, really, most of this chapter is just like, hey, here's a new formula, use it, right? And it's, yeah, you gotta know, yeah, you gotta have the whole bag of tricks. You gotta have like your whole like Batman utility belt with every one of these identities ready to go at any time, because you don't know when you're gonna need the batarang or like your little grappling hook or like some little poison vial or something. I don't know.
Isn't the shark spray?
What is he? What?
The shark spray?
The shark spray?
Isn't that the one from the 60s? Where he's
Maybe, that sounds familiar.
Shark spray?
Wow, that's pretty amazing. Oh, that sounds familiar. That sounds like something I should have known. Shark spray.
I think I've seen what you're talking
Well, if my online viewers overheard that, we're talking about back in the 60s, 70s version of Batman, he had shark spray on his utility belt. Feel free to address that in the comments below and maybe link in some video footage that you find online of said shark spray. Maybe even link a Wikipedia page in there for us. That'd be great. I'm sure it'll get liked up to the top. So anyways, cosine of 2 theta. What's the formula for cosine 2 theta? Wait a minute. The formula? There's 3 of them. What? But now, guys, think about this. I can pick either of those formulas to work with. Which one should I work with? I've got 3. What do you think? Why do you like that one so much? Right? I like this formula the most right now because I have cosine theta. So I could just plug cos theta in there and square it and double it and -1. I don't want to use this one because I don't even have sine. And I don't want to use this one because even though I have cosine, I'll still have to do the work to find sine theta using a method not unlike this here or this here, right? So, so that's what I'm pointing out, is for cosine, you kind of get to pick your formula, which is nice. So, let's see. Oh, my projector just went out. It's cool. Hey, we're back. Good news, everyone. So 2 times cos theta. Well, I'll write out the formula. I don't know. What do you guys want from me? What do you want from me? So that's the same as 2 times 4/9 all squared -1. So that's the same as 2 times 16/81 -1. Yeah, I can write pretty fast on my little tablet over here. 32/81 minus, hey, I need a common denominator. 81/81. So let's see, 32 minus 81 is equal to negative, let's see, it's Friday afternoon, people, 49/81 is the value of cosine 2 theta. Now notice this problem also said that theta has its terminal side in the first quadrant. Why is this negative then? Oh, sorry.
Subtracting 1.
Yeah, 32/81 minus 81/81. Guys, how am I getting a negative value for cosine 2 theta here? It said theta was in the first quadrant.
There's 2 of them.
Well, think about this. Actually, we might even, I mean, sure, we could use some, cos inverse or arc cos to actually find out what theta is. But I want to point out, if theta was this, then 2 theta would also have been in this quadrant, right? And then this should have been positive. So what does that tell you about the original theta? It must have been bigger than what number?
45.
Bigger than 45, so that 2 thetas would have put us into the second quadrant where cosine is negative. Aha. All right, so yeah, so does that make sense? Right, because if it was, right, 45 exactly, then 2 theta would have equaled 1, something like that. So just want to point that out. It is possible, man, I'm undoing all sorts of stuff here.
Cosine goes positive, negative, negative, positive here.
I'm going to agree even though I didn't process that. So let's look at another thing here. I think we're going to derive something here for us. So we've been talking about double angles. What about some half angles, friend? That sounded like excitement. Let's see. Let's see. Cosine of 2 theta. I'm starting with this thing right here is the same as 2 cosine squared theta minus 1. We were just dealing with that, right? If I want to find a half angle identity, all right, that means I would want to go from a regular theta. All right, well, this is going from 2 theta to a theta, right? This is kind of a half angle identity thing right here. If I can solve this for cos theta, then I'll have something in terms of an angle that is double it or vice versa, half it, depending on what you're looking at. So all I have to do to find the identity for the half angle is solve for cos theta from this. All right, is what I'm going to do. Yeah, you can go. You can go if you want. Yeah, sure. So let's solve for that. So cos 2 theta plus 1 is equal to 2 cos squared theta. Now what do I do to both sides to solve for cos theta? Div 2 both sides, I like it. So I'm actually even going to flipperoo this over here. I don't know why the mathematicians decided they like the 1 in front. I don't know, sure, that's fine. Equals cos squared theta. And what would I do to both sides here? Root both sides. Plus or minus over here, don't forget it. And I end up getting that cos theta is equal to plus or minus the square root of 1 plus cos 2 theta all over 2. Now, this plus or minus depends on which quadrant theta is in. Okay? So don't just assume that you have 2 answers here. We're going to only have 1, but we're going to select it based on that. So it turns out you can imagine that if I use the cosine formula, cos 2 theta formula, that's 1 minus 2 sine squared. If I solve that for sine theta, I'd end up getting a similar sort of formula. I'll give you these formulas right now. So these are the half angle identities. And you guys already have these on your sheet that I was so kind to equip you with. Oh yeah. It's because I play video games. You equip things. Yeah, exactly. So here are our, man, that was too many R sounding things at once. Here are our half angle identities. All right, notice first of all that I kind of changed something here. What's different between this one and this one? Yeah, I changed this theta. I rearranged with basically alpha over 2. All right, or yeah, down here technically. Huh? So that way it ends up working out. So I can end up using that. So if I know an angle and I want to know half of its value, it's going to end up giving me what I'm looking for. Okay, so that's the only change, but I think you guys believe that last step that would bring me there. So here's my half angle identities. So sine and cosine both derive from the cos 2 theta formulas. And tangent, how do you think we would have derived tangent? Yeah, tan theta is equal to sine over cos, so yeah, if I just literally take this and divide by that and simplify, I get the tangent. Now, question, why, there we go, why does tangent have this restriction? Why can cos alpha not equal -1? What happens if cos alpha is equal to -1? What happens if this is a -1? And it's dividing by 0, and 0 is undefined. Okay? So this is due to div by 0. Okay? Question, what angle would cosine alpha equal -1? What can alpha not equal? When is cosine equal to -1? On a unit circle. 180 degrees. Okay? All right? So that's worth pointing out. And actually, thinking even further, if alpha is 180 degrees, that means I'm trying to find the tangent of 90 degrees. And you guys already know that tangent of 90 is undefined. So it's all interconnected. It's all making sense. Good stuff, good stuff. All right, let's do an example of this. I'll take that snapshot. That's good enough. It's not like I'm some professional quality video production expert. I'm just a teacher with a YouTube page. It's good enough. It's good enough. But seriously, fans on the internet, I love you guys, especially that one guy in China. You're the best. So let's see. Use a half angle identity to find the exact value of each function. So if I'm looking for cosine of 67.5 degrees, what? That's going to be the same as cosine of what divided by 2? All right, and we're thinking that through, and we get 135 degrees. And now, wait a minute, cosine of 135 over 2, I can just use this like little formula right here, can't I? All right, so I'm expecting this to equal the square root of this big fraction, 1 plus cosine of what number? 135, okay? This right there is the common mistake. People will put 67.5 here, but notice the relationship here is alpha goes in here and half of alpha goes there. So this is half of alpha, right? There we go. And that's over 2. Now, question, this said plus or minus. Which one do I want in my situation? Oh, let's see. It looks like it's a heated debate going on here. What quadrant is this in? First. So I know this is 135 degrees, but the angle that I'm finding actually is 135 divided by 2, which is 67.5, which is first quadrant in which cosine is positive. Okay? Good, good, good. So I'm looking for the positive square root there. So once again, let's just remind ourselves, based on quadrant of 67.5 degrees. All right, is where that was from. That was like the scribbliest, ugliest writing I've ever used. Ugh, wow. All right, So this is the same as 1 plus, or is it, cosine of 135. Let's do a little work. 135. Right here. What's the reference? 180 minus 1, or
45.
so that's 45 degrees. Is cosine positive or negative? Okay, so it's negative. So this portion of the formula, okay, is equal to the negative cosine of 45 degrees. All right, so notice I had a sign change here due to this. Okay, if I was finding the cosine of a different angle, it wouldn't have been a problem. All right, it would have stayed positive. So let's see, what is cosine of 45 degrees? Root 2 over 2. I agree. And now, from this point on, we're just doing lots of fraction work. All right, lots of fraction radical work. That's all this, all right? So up to this point, you've used your trigonometry skills, your trig identities. From this point on, this is going to depend all on your fraction and radical work, all right? So bear with me, all right? So you might want to go back and refresh on some of that if we need to. Equals. Now, I've got two things divided by 2. You could multiply by the reciprocal. You could break this fraction bar up into 2 and 2. That's, I think, what I like to think of it as. But, I mean, really, as long as you're obeying the laws of math, you'll be fine. But this is the same as 1/2 minus rad 2 over what's this divided by that? Or this divided by that, more specifically. Square root of 2 over what denominator? 4. Dividing a fraction by 2 is the same as doubling its denominator. Okay? So here's some more fraction work. I can't subtract these. They've got different denominators. I got to multiply this one by 2 over 2. Square root of 2/4, or how about this? Square root of 2 minus the square root of 2 all over 4. And now I can break this radical up into top and bottom. All right. Square root of the numerator. Check this out. I have a nested square root. How cool is that? I love it. And the square root of the denominator is 2, and we're done. All right. I couldn't leave the problem like this previously because technically this was behaving as though there was a square root of 2 in the denominator. All right. Technically. Actually, I wonder if there's some other ways I could do this from here, but either way, this way works. I like it. Let's do one last example. Your hand hurts. Oh, man. Man. All right. Everyone's favorite.
Oh.
No.
I hate when
Actually-
I do the homework and I see verify and I'm just like, yeah.
You're just like, I don't need to verify this. I believe you. I think it's true.
That's the way I
I'll take your word for
I've
it.
gone over this math book. Like, come on.
Every problem that we've had so far, you know, it works out.
So, all right. This is actually there's a step in this problem that will completely seem ridiculously out of left field. But I think I've got a good way to explain it to you. I'm going to work on this right-hand side for a little bit. Everyone loves the right-hand side here. What do you think we could do on the right-hand side? Let's do the classic thing. Let's change cotan to what? Cosine over sine. Let's do that. That sounds good. Right? Sometimes, when in doubt, rewrite things in terms of sine and cosine. All right, now I've just created a complex fraction here. So what I'm going to do is mult top and bottom by LCD of the denominators. Denominis. Sounds like some sort of delicious M&M treat. Like, now smaller, more enjoyable, fun-sized denominis. Sounds delicious. So, what is the LCD of the denominators? Sine theta. All right. So I'm going to multiply by sine theta over sine theta. And being very careful to make sure I kind of distribute, because that vinculum is a grouping symbol, so technically these are behaving as though they are parenthesized. So let's see, I'm going to have sine theta cos theta, or no. Multiplying by this first fraction, the sine thetas cancel out, and I'll have cos theta, sorry. And then here, I'll have minus sine theta over. Here the sine thetas cancel out, so I'll have cos theta plus sine theta times 1 is sine theta. All right. So let's think about, now this is the next step that's going to be the crazy one, because crazy. This would have just, I mean, you could have discovered this just by like playing with the math on things until it worked. But let's think about, what is sine of 2 theta equal to? I think that was one of our identities we just learned today.
2 sine theta cos theta.
All right. So this is the same as, let's work on the left-hand side for a little bit. That's the same as 1 plus 2 sine theta cos theta. Okay. Now the numerator, what is that equal to? I technically have 3 options. So I'm going to leave this unknown for now. All right? And this is where things get interesting. I want this denominator to somehow turn into that denominator. The fact that I'm seeing some sort of like 2 sine theta cos theta thing, I'm thinking of a pattern where I've seen something like that before.
That's the middle one.
Yeah, that's the middle term of a pattern. And this is like really absurd. Like, why would you have thought to multiply this by something that would give you that? All right. So what would I have to multiply this denominator by to make this pattern work?
Cosine theta sine theta.
Yeah, by itself. And if I'm multiplying the denominator by it, I also have to multiply the numerator by it. That step is the weird one. And this is the link. And I don't expect that you guys necessarily would spot that right away. But yeah, that's the only link that you really had to go off of. So, let's do this.
Do they honestly
Hey, well that's why I'm showing, sometimes with proofs it almost feels like a trick or a little manipulation that occurred that suddenly explains it. So that's why I am showing this to you so you can kind of like see these little tricks and hopefully eventually become familiar with some of the stuff that happens. For the numerator, a plus b times a minus b, that's just a squared minus b squared, right? And I think I like that. And the denominator is going to be a squared, so that's cos squared theta, plus 2 cos theta sine theta, plus b squared, which is sine squared theta. Now, why do I like my numerator so much? What do I want my numerator to equal?
1 plus 2 sine theta cos theta.
My numerator?
Oh, no, I don't know.
Numerator. I'm trying to get it equal to cosine 2 theta. Look at your formulas for cosine 2 theta.
Second one.
That's like directly one of the formulas for it, right? So that is cosine 2 theta. That's good news. All right, my denominator, I want this to equal that. You see what I can do?
Cosine squared theta.
Oh yeah, Pythag identity. So this is equal to, ready? Cosine 2 theta. And the denominator is 1 plus 2 sine. I'll flip those around just to make it really match. Times cos theta. And I'm running out of room here. And that's equal to ditto, ditto, ditto. And up here is still cosine 2 theta. Whew. Verified. Yeah, so that step right there, that's a tough one to spot, to be honest. Got to tell you, that's a tough one to spot. Well, thanks for watching, Internet friends. Have a great day. Bye-bye.